These notes go with section 3.5 in your textbook, and they tell you what to do when you're solving inequalities that involve multiplying and dividing. The only difference, the thing we need to watch out for when we're multiplying and dividing as part of solving an inequality, there's one difference from adding and subtracting to solve an inequality, and that is this. When we multiply or divide by a negative number, we need to flip the inequality sign around. So let's see what that looks like in practice. Here's an inequality. Negative 4x is greater than 6. To solve this inequality for x, to figure out what values of x make this inequality true, I would need to divide both sides of this by negative 4. Notice that I'm dividing by a negative number here. When I do that, my inequality sign is going to go from being a greater than to a less than. I have to flip the inequality sign around. Now I have x by itself on the left-hand side and 6 over negative 4, which simplifies to negative 3 over 2. It's really important to notice that it's only when the number I'm multiplying or dividing by is negative that I switch the inequality sign around. Let's walk through a couple of examples to highlight some common mistakes that people make when it comes to multiplying and dividing in inequalities. First, let's look at this practice problem A. I have 12x is greater than or equal to negative 60. In order to get the x by itself here, I would divide both sides of this by 12. I'm dividing by a positive number, so I don't have to flip my inequality sign around. I'll have x, I leave this inequality sign alone, is greater than or equal to, and even though the stuff here is negative, negative 60 over 12 is negative 5. The fact that the number on this side is negative doesn't matter. It's only when I multiply or divide by a negative number that I flip my inequality sign around. Here I have t divided by 5 is less than 3. In order to get the t by itself, I'm going to multiply both sides of this equation by 5. 5t over 5 is just t. I didn't multiply or divide by a negative number, so I don't need to switch my inequality sign around. I leave it as it is. Equals 3 times 5, which is 15. In the last case, example C here, I have 10 is greater than or equal to m divided by negative 2. To get the m all by itself, I'm going to have to multiply both sides by negative 2. Now in this case, I am multiplying by a negative number, negative 2 in this case, so I'm going to switch my inequality sign around. Now on the right-hand side, all I have left is m, and on the left-hand side, I have negative 2 times 10, or negative 20. So notice that in two cases here, we didn't flip our inequality signs around because we were not multiplying or dividing by a negative number. But here, we did flip our inequality sign around. Now, let's look at some examples of word problems and phrases that require inequalities in their solutions. So here's an example. Catherine has $123 in her checking account. With the extra earnings from her job, she can deposit $50 per week. When she reaches $500 in the checking account, she plans to open a savings account. And we need to model this situation. So let's see. We need, for the total in her account, to be greater than or equal to $500. Because it says when she reaches $500, so as soon as she gets $500 or more, she's going to open a savings account. So we need for the total money in her account to be greater than or equal to $500. Now let's see if we can write an equation that describes the total money in her account. Well, the total money in her account is the money she started with plus the money she puts in each month. So that has to be greater than $500. Well, the money that she started with was $123, plus the money that she puts in, well, she puts in $50 a week, but it doesn't tell me in the problem how many weeks it's going to take her to do that. So I'm going to define a variable. W equals the number of weeks that she's depositing money. So the amount of money that she's put in over all those months is $50 times W, the number of months. And that has to be greater than, the number of weeks. And that has to be greater than or equal to $500. This is an inequality that we could solve. So let's go ahead and take this inequality. 123 plus 50W is greater than or equal to 500. The first thing I have to do is subtract $123 from both sides of this inequality. I haven't multiplied or divided by a negative number, so my inequality sign stays the same there. So on the left-hand side of this inequality, all I have left is the positive 50W. And 500 minus 123 is 377. And then I divide both sides by 50. And I have not multiplied or divided by a negative number, so my inequality sign doesn't flip around, it stays in the same direction. 377 divided by 50 is 7.54. So that means that she needs to have been depositing money for more than 7.54 weeks. That means that when she makes her deposit at week number 7, she doesn't have enough money. But when she makes her deposit at week number 8, she will have enough money. The next problem here is just a verbal expression that we're going to turn into an inequality. 3 times a number, that's going to be our variable, so 3 times x, is at least, that means it's bigger than or equal to 45. I can divide both sides of this equation by 3, and when I do that, I get that x has to be greater than or equal to 15. I didn't have to switch my inequality sign around because I'm divided by a positive number. Next, a number, that's x, divided by 2 is no more than 6. So it could be 6, or it could be 5, or it could be 4. It needs to be something less than or equal to 6. So to solve this, I multiply both sides of the equation by 2, and I get x is less than or equal to, I don't switch my inequality sign around because I didn't multiply or divide by something that's negative, 12. So there's my solution for number 3.